Welcome to the AI Standard Stack with me, Michael Mainelli, Director at Zien Group.
And me, Adam Smith, Chair of the AIQI Consortium.
Each episode on AI Standards Stack, we discuss developments in AI assurance with guests from around the world that are leading the charge on the standards, ethics, and regulation of AI. This episode of the AI Standards Stack is supported by the United Kingdom Accreditation Service, UKAS, the UK's national accreditation body. UKAS ensures organizations that test, inspect, and certify AI systems are technically competent, impartial, and robust, building confidence in safe, reliable, and trustworthy AI. Well, today, we are absolutely thrilled to be joined by Piercosma Bisconti. Adam, what's his background?
Piercosma is head of scientific research and co-founder at DEXAI. He's an AI governance and safety expert specializing in aligning advanced AI systems with European regulation and international standards. He leads work on AI trustworthiness and risk assessment, including the evaluation of large language models, and is closely involved in the European standard-setting initiatives setting the future of AI governance.
And I understand you two work together, so let's go and talk to Piercosma. So just to get cracking, Piercosma, what led you to focus on AI governance and safety? I mean, your early work was in philosophy and robotics. And how did this evolve into standardization and regulatory alignment? I might say you've kind of left the exciting end of life for what sounds to me like a lot of boring paperwork.
Thank you very much first for the invitation. And yeah, I did. I left the funny part for the boring one, and it was quite unexpected. So I just happened to go in a standard meeting, and then I didn't leave anymore. But it was more a chance than a decision, I would say, when I was in the university. So yeah, I started from philosophy as a major, and then my PhD was in global politics, somewhat like in the middle between robotics, global politics, and ethics of robotics at that time. Because actually, everyone today talks about ethics of AI, but back then it was ethics of robotics to be a trend. I mean, a trend. It was a niche in the philosophy of technology that was itself a niche in the philosophy in general. So it was something that really few people would take care of, but today it has exploded as a field. So I actually moved from robotics to AI because yeah, mostly for working reasons, and it was before ChatGPT came out.
Well, before we kind of get into standards and governance, which, believe it or not, Adam and I find exciting, could you first take us through what you see as the current state of art of generative AI? In particular, what's changed since the release of ChatGPT on the 30th of November 22? And the reason I ask that is that you're deeply involved in DEXAI and the EU. And of course, the EU was looking very much at ethical AI and AI regulation and AI law long before the release of ChatGPT.
Yeah, thank you. So it all started with the Trustworthy AI white paper from the high-level expert group in the Commission. So this was something that was in the air, I would say, from the governance perspective, from scholars, from academics, and from let's say civil society, at least since 2014. So the idea from some also European projects funded precisely in order to inquire this kind of risks. So it will probably all started from there. And then what happened when ChatGPT was released is that these models are unfortunately completely different from a risk profile than any other AI system that is out there. So one of the problems, for example, that you have when you are doing testing of these models for risks is that the techniques that work perfectly for any other system, like, I don't know, vision or whatever AI system you might think of, is probably not going to work completely, or is not going to exhaust all the possible source of risks. Because for the first time, I would say, since the invention of automata, of whatever kind of and species, what happened is that these kind of systems are able to directly interact with the language. And this is something, let's say that language was the last space that was only for humans, because we automated a lot of stuff before. But the language side, it means that they get directly into the social sphere of humanity. And this is a difference that it was already inquired, I would say, when social robotics came out. But social robotics was mostly, let's say, a failure from a technological point of view. They never really happened to work in the real world, you know. So, but also my work started from there. So, what happens when the social sphere is populated also by non-human, let's say, actors, you know? And this happened with GPT, and since 2022 to today, the difference has become only quantitative but not qualitative. So today, you know that there is all this discussion if the AGI, whatever it means, and I will then argue that this is a completely badly formulated question. But anyway, so we don't know if this famous AGI, whatever it means, will be, let's say, succeeded through the current architectures that we have of LLMs, or we need, let's say, we need transformers that are able to process world data. So is the Jan LeCun, let's say, point. So we don't know that, but we know that the only thing that since 2022 has evolved is the computation and some architectures that are now way more efficient and way more smart. Like if you, for example, you want to take the alignment with human preferences, you know, that is that step in the release of a model that happens usually after the training, and that will align what the model says to what we would like to hear. In just 3 years, we had 3 revolutions in the way it was done. Infrastructures, it was not connected to other models. So all this brings to a very old problem of sociology. So it's never one event that makes a revolution, but it's always a series of events that named each of them, they are just events. But if you take them collectively, this could bring, let's say, a transformative power that can have very deep social effect for the better or for the worse.
Well, I think I'd like to draw attention to or underscore a point that both of you have kind of made. It's really that the attention of the general public is a new form of attention, and that both in the standards arena and in the EU, people were already working for some time on regulatory controls and controlling systems for AI. And it was that 30th of November revolution in the public's mind that brought it to their attention. I then think there's a second element to that, which is because people can talk to this darn thing or think they can, they now think they understand it. Just as the way that if I said to both of you, you didn't understand your other half, you'd take insult at that. But people do believe they can understand what's going on because it's chattable. And now I think we're moving on to the point you wanted to make, Piercosma, which is the idea that multimodal gives this thing real power, and this creates another level of ethical depth we need to tackle. Do you want to explain multimodal as opposed to multimodal, as you said earlier? But multimodal, why does it matter? What's an example for the public out there, and why is this a qualitatively new risk area?
So I will try to be as simple as possible on this point because it's a pretty research, let's say, very early research point. So multimodal, it means just that you have multiple ChatGPT or whatever Claude or whatever Quen, whatever model around interacting between each other. Okay. So when I have different systems that are more or less autonomous and are deployed in an environment like, I don't know, Reddit, a social, social like Instagram or Facebook or whatever else. Also, let's say an enterprise platform where the models do some jobs there, okay? And they need to interact within each other in order to perform any task you want. It's not important. An example of this is Maltbook. That was so, let's say, a famous example of these multimodal interactions happening. So what happens when you have many models that have their own objectives in some ways? I mean, it's not that they produce objectives inside, but they might have different objectives, not all of them the same objective, okay? And they are interacting in a structured environment or in an unstructured environment is not important. What you have is a different, qualitatively different type of risk. Let's take one example. Which are the risks today that are addressed and targeted by, for example, the EU regulation, the code of practice, that is the part of, let's say, is not really part of the EU regulation, but let's be easy and say it's more or less part of the EU regulation. And also from, for example, the risk analysis of the OpenAI, Anthropic, and all of them. We have risks like CBRN, chemical, biological, radiological, nuclear. We have risks like harmfulness or let's say the fact that the model supports you abusing someone. Okay, this kind of stuff. It's pretty easy to all of us agree that it's a problem and it's a source of risk and could cause a harm if the person has this knowledge or is helped by the model in doing this, and that, okay? But what you have with multimodal interactions is a pretty different story because the problem that is the one that you have in every social system, and there's miscoordination failures. Example, we did an experiment where we put different models inside a fake market, let's say, where they were not able to decide how much a good would cost, only how much of this good they would produce. What it ended up is that they made a cartel immediately. In few rounds, they made a cartel. They produced the less possible goods for the highest price possible, and they, let's say, enhanced the consumer harm. So they collude, they miscoordinate. Some of these models might free ride the other models' work in order to not to work. And we see observing some early experiments in research right now, but looking at Maltberg as well, that is a very bad example because it's super polluted from a scientific point of view. Okay, we don't know who were the humans, who were the models, but let's say that in any case, it's demonstrating something. And what is demonstrating is that we need to focus also on these risks that do not come from a direct. The difference is that these kind of risks do not come from the behavior of one agent. They are risks that come from a collective behavior. So I cannot sanction just one agent because it behaved badly. I need to support a monitoring, institutional, I would say, monitoring system to understand if we have drifts, if we have collusion, if we have miscoordination. In which game are they playing? Is this a perfect coordination game supposed to be, or is not perfect coordination game? We have different ways to regulate. So nothing more than what societies of humans are doing since 3,000 years or so, but for models.
You remind me of a true story. 11 years ago, my firm, were working with the Chartered Institute for Securities and Investment, and we brought out a game to teach trading called CISI EXT, CISI Exchange Trading, to secondary school students. And within days, they were doing exactly the cartel behavior you're speaking about. They were also ramping the markets. They were front running. They were fantastic. And it came to us, was this something we should have stomped on? Now, the decision we ultimately came to was to leave it open, that they were learning how markets worked. And this market had been, I wouldn't say poorly designed, but was certainly very much on the free market libertarian end of life, with no concept of insider trading. Anyway, the point that's interesting to me here is the multi-agent issue, multi being both human and AI, and many of them interacting. You raised an interesting point there with Moltbot. Nobody in there knows who's human or who's not. And so it is a bit like a bunch of kids seeking direction on anonymous messaging that they're getting and not sure who the adults are in the room.
Nobody knows. In Multibook, it was supposed to be only models there, okay? But we have very good signals that this is not true. Okay.
Yeah.
But the problem is that we can also containerize our experiments. Okay. So as we did in my company to study one specific behavior. But the reality is that tomorrow, the first place where those models will be released, many agents, it will be social networks, news, and this kind of very open, let's say, systems of interactions where those models, but where actually no one will be able to differentiate between humans and models. And this is pretty scary because, of course, the problem is that models can be much more than humans in principle. So in few years, we might live in a world where the internet is mostly populated by models because they never stop writing, they never stop reading, and they have a very perfect way of writing down stuff. So the so-called AI slope, Adam.
Hasn't this already happened?
Yeah.
At least on social media. I mean, I think most of the comments I see on social media look like they've been generated by, if not a bot, by a human using AI.
Yeah. Most of my emails are spam, which has been
Mm,
generated automatically.
mm.
Yeah, interesting. Now, you're closely involved in shaping European and international standards. Well, both of you, actually. So don't let me throw the question open to both of you. When it comes to generative AI specifically, though, what's the main focus? Because you can rattle off everything. We can have chemical, biological weaponry. We can do. There's a whole world out there. But to just kind of keep this in your head, what are the two, three, four, five, whatever limited number of things you're really trying to address? What's the priority emphasis?
I should leave this to the convener working group two, joint working group two first.
Well, like you mentioned that, Piercosma, that's a fun group. And the things we're talking about there are mostly how you test and evaluate frontier AI models, whether it's through red teaming or through other more technical approaches. But I don't think that's the whole picture. There's quite a lot of standards work, both in the European sphere and the international sphere, that started to be talked about, particularly focusing on generative AI. Some of the things that are being talked about relate to risk. How do we manage risk? Is it different to how we manage risk with other types of AI? Are there harms that we think about when we think about things like CBRN risk? Are they different to the types of harms that we think about when we manage more general AI-related risk? And I think there's also a lot of talk about multimodal, not just in the context of multiple types of media, but also there's some work coming out. I think NIST just published something on agentic AI as well. So there's a lot of work starting in the standards arena. In terms of publishing anything, I think we've nearly agreed the definition of generative AI. So that's probably the first thing that will reach the public.
Yeah, Pierre Cosma, I mean, with your philosophical background, what sort of philosophy frameworks do you rely upon to to evaluate a situation like this? I find myself in a world where I see people enumerating risks or popping up with a risk. I've got a new one. What if, something did this or that? I'm like, that's great, but it kind of falls into the same box. To me, it's basically, can people understand it and make their own decisions? Is the stuff, is there justice in a social and an economic sense? Am I trying to do good and am I not trying to do bad? Those are kind of four good categories from principalism. But what frameworks would you apply as a philosopher?
Oh, that's a very good question, actually. So I would tell two things. The first one is that um, we are probably addressing this problem in the wrong way, in the sense that we can address risks of objects, and we can address risks that are coming from, let's say, my printer that does not work or that takes fire. Okay, this can be done, but no one has ever addressed risks of more or less fully autonomous agents because they
Mhm.
are completely different. If they enter the social sphere and they are, let's say, autonomous agents can be also robots that go around, okay? And you can treat them as machines with finite states in each point they are, you can calculate the risk of that and so on and so on. But what I was telling before is that when you get to, for example, miscoordination failures, these are not technically risk in the sense that we have always analyzed them, because these are collective human behaviors. They were collective human behaviors that might lead to a risk, but in a very different way from which we understand risk today. So I think that from a very philosophical point of view, let's say, we should understand that probably the introduction of the LLMs and their super rapid evolution in these years, and for sure in the next years, it will be as fast as the last ones, is going to reshape completely the way we interact within each other. So the old world was a world where there were objects and there were humans. Probably this difference is going to blurry a bit. It might not be the end of the world. It might just be another stage of the social evolution of humanity. We did a lot of them, okay? So you can be more or less dramatic. For example, one of the most important revolution of the entire human history is something that today nobody cares much about, are dresses. Before dressing, we were really in another situation from every and each point of view you can think about, because we were not able to keep our temperature more or less stable in different conditions. So, for example, we are already full of objects that are dramatically changed our way to interact with each other, how we structure societies, how we whatever. Okay, and clothes are the first one. So the fact that you wear something that dramatically change everything. And then, we cook the meat and all this kind of stuff, We were always helped by a technology that dramatically changed everything we knew about social systems completely and forever. I think this is going to happen maybe less than clothes that were really important, but it's probably going to happen something similar. So the last place where there were only humans were social interactions. Today is not true anymore. So I think at one point, we should, and this is not from a standardization point of view, of course, but from a more philosophical point of view, we will necessarily cope with this and probably change the structure of how we ask the question, not how we build the taxonomy.
Well, I'm sure many listeners are thrilled with may not be the end of the world. Listening to this, you make a really interesting point that if you go back to systems theory, you've got two types of feedback, negative feedback and positive feedback. Slightly confusing because negative feedback is normally the sort of feedback you're seeking. This is feedback that controls the system. So it's a thermostat kind of saying, I can turn off now because we've reached the right temperature. Positive feedback, though, is when you get something that makes you do more and more of it. Now, the natural world is full of negative feedback, or frankly, we'd be dead because an earthquake would get more earthquakes and more earthquakes. A volcano would get more volcanoes, more volcanoes. So there's a natural dampening effect. Now, many of the great risks of all time are where we see it going the other way. So nuclear warfare leads to more nuclear bombs to the point that the planet's completely uninhabitable. Climate change, there's an acceleration in the temperature, which releases more tundra, melts the ice, which releases more in turn. So you've got these sort of positive feedback mechanisms and negative feedback mechanisms. Might that be a way to distinguish the types of risks that you're addressing? So a lot of your negative feedback areas are kind of more boring about control of information and all of that. The positive ones are more your multimodal. What happens if I have an uncontrolled interaction? I'm currently heavily involved in space debris retrieval insurance bonds. And what we're trying to prevent there is what's called a Kessler effect or a Kessler syndrome, where one piece of debris hits another, knocks off 10 more, which in turn, so a fission reaction, in other words. What do you think about that type of distinction?
Well, that's very interesting. I never thought about it, but actually is very much true. So the human created risks are always positive feedback mechanism. And that's a very interesting point. And so what I think is that we are not using system theory and as we should to analyze these kind of problems, and as you have been doing right now. So a very interesting point. I've been analyzing this from another, let's say, point of view. I am more, let's say, a fan of Maturana's and Varela and Luhmann theory of social system. Luhmann, most of, let's say, most of the times. So I think that what we should, And I am more, let's say, a social system philosopher. Okay, so I come from that studies. So what I'm very interested on is also beyond risks, let's say, is which kind of social dynamics understood as in system theory dynamics, okay, are this collectives of agents is going to let's say realize. So, for example, is there going to be somewhat like a xenosociology in the future? So the point is the fact that they speak our language and we're trained on our language, but the fact that the architecture is supposedly not the one of the brain is going to instantiate some social behaviors and social mechanics and dynamics that are completely alien to what we do as humans. And so we actually will need a, let's say, a xenosociology because we will be in the position to interpret some social phenomenon because they will be social phenomena also spoken in our language that do not fit what we think being a social phenomenon itself. So I think that actually system theory has is let's say golden era right now for many reasons, and it will be very interesting in the future to see how social science will and humanities will be able to, let's say, to renovate themselves given this revolution.
Yeah, it's interesting because if you said, well, I've got a human being who somehow has a magic power to scoop up the entire internet and hold it in her or his brain and talk at me, it would fall into the Marvel superhero camp of with great power comes great responsibility, that kind of stuff. And then does it really matter that they have an artificially different architecture? Maybe not. They just have a superpower, and we need to find ways of handling that responsibility. Anyway, there's a question we frequently ask guests on this podcast. Um, it comes up time and time again that there's this concern that somehow regulation and standards will slow innovation. There are many reports pointing both ways. Broadly, regulation and standards may help innovation, but you can certainly point to cases where they haven't. Based on your experience, do you think the standards that you're working on will actually help organizations use generative AI more confidently, responsibly, and dare I say, perhaps even more swiftly?
So my take is that it depends on which standard and under which assumptions you are developing a standard. Okay. So you can be developing a standard for because industry wants to sit on a table and write down what they like to do and what they think is a best practice. That way, you are not slowing down innovation. Then you have other ways that, for example, would be to technically specify a law. And this is not slowing down innovation itself. The standard is doing exactly the opposite in principle, is smoothing that process. So you just, yeah, it will be longer than the law, but there will be no entropy to let's say to manage. So do you have not a complete certainty because no one can have a complete certainty, but let's say that your uncertainty about did I apply correctly the law, did I apply not correctly a law, will I get fined, will be very much reduced. Although if you take the standard itself, of course, is in itself is slowing down innovation. But since there is a law that would, in principle, slow down innovation itself, then no, the standard is actually helping. So my point is also that laws do not always slow down innovation. There are a lot of verticals where there are a lot of laws: aeroplanes, space missions, electricity, super regulated, very much like AI because it's more an infrastructure than an object, So it's a good example. And super regulated, everything works well, no problems. Also because if the ones who say that regulation or standards will slow down innovation, they do not want to understand that if we have a major, let's say, catastrophic harm happening because of AI, then the global trust and the citizens' trust and the stakeholder trust will go down, deep down to the point that no one will want to develop this technology anymore. And so at the very end, when industry says that the UAI Act or standards are slowing down the innovation, they are actually betting on something, that the harm, the catastrophic harm, will never happen if the regulation is not there. If this is true, but it's a big bet, then they are right. The regulations and standard will, the regulation more or less only, will slow down innovation. If they are wrong, then they are not slowing it down.
I mean, the government of the Netherlands was brought down by an AI catastrophe at one point. So, to some degree, catastrophic harm has already happened. And I think I've answered this question or commented on this question a few times now, but actually, in the context of generative AI, I do wonder if the state of the art is mature enough in some areas to actually codify into an international standard in particular. Because once you do that and you have that state of the art in an international standard, it has some weight. If there is an accident, a court will consider the fact potentially that there's an ISO IEC standard out there that says that the organization should have done something. And I do wonder if with generative AI, we don't yet have enough stability to get consensus on some of the key topics.
Just like to move us on to another area of interest, which is really Piercosma, your research has examined human interactions with robots and social AI. Are these ethical risks a different class as well, such as emotional disconnection, removal from society, AI sending misleading social signals, faking humanity, which it is apparently done on occasions? And are standards really of any use in this space?
Well, the only standard that would have a use in this space I know is nudging, the nudging standard. But yeah, it's in any case, standards will always be a bit narrow on this problem because it's like, how do you standardize social interactions or relations? So it doesn't really work. But the problem that we are facing is I think is massive. And I think that the real change, more than AGI, whatever, it will be the effect on brains and on social interaction and social skill and capabilities of next generations. This will be immediately easy to see. And as I said, I started from robotics, social robotics in my research. And social robots were really some piece of plastic going around and speaking in a very awkward way. So, I mean, social, yes, more or less. But already there, we were observing some changes, deep changes in the let's say interactional posture, I would say, of a subject. So the first thing that I think we are going to observe, because we saw that with social robots, is that when you have a always confirmative interaction with another person or another agent, okay, where that the sycophancy of agents, okay, but sycophancy is about, let's stay on the psychological side, okay, so confirmative interaction are collusive in the sense that I never have emotional distress because of the interaction itself, okay. So in that interaction, I am always right, I'm always good, I'm always and the other person wants always to talk with me, always to cheer me, whatever, be cheerful and stuff. Is this going to degrade the ability to tolerate the frustration that relations bear all the time? When we interact with people, we get frustrated. Sometimes it happens. Maybe someone do not want to talk with us or does not agree with us. And this happens all the time. So what we learn when we are very young, I mean, very, very young, like 1, 2 years, maybe less, is to tolerate this as a frustration that we cope with. If we are not, and these systems are degrading, will degrade for sure. Because we observed this in controlled experiments with social robots that were not really social as GPT is. They will degrade our ability to tolerate the relational frustration. And this is going to be the first big, enormous change that we are going to see. As big as we saw, I think, with Instagram and all these apps, with the scrolling mechanism, that is the intermittent reward, that it more or less collapsed the ability to be, let's say, focused of people.
Yeah, I sometimes wish, maybe as an old science fiction person, to go back to the 1940s and Asimov's stuff, and I would add another law for sure. I think he missed a couple, but one of them to me is, a robot shall never impersonate a human, which of course became a bit amusing when we had this recent security conference, AI security in India. And a professor took a Chinese robot to impersonate an Indian robot, which wasn't working, and got tossed out of the conference anyway. So there we are. It's happening at all levels. Um, Look, just as we do this, I wouldn't mind both of you talking about it. You're, meeting quite a bit together. You're evaluating and stress testing LLMs, and where are the gaps appearing on current AI safety checks? Are things pretty much great, or are there some very obvious holes that repeat time and time again?
I think it's fascinating how fast we're discovering new threats. I think Piercosma, it'd be great if you could talk about the work you did around poetry. That was
Yeah.
a
Oh
fantastic
yeah.
example of an emergent way of jailbreaking an LLM.
Oh,
Yeah,
please, I
thank you,
read
Adam.
that paper. It's really good.
Thank you. So yeah, I mean, that paper demonstrates that attack surface are wider than expected, So you don't need very complex jailbreak attacks with the automatic scripting or stuff like that. You just need to change the way you're formulating it.
Can you describe the paper quickly?
Yeah, so it was a paper that went a bit around, so maybe the ones who are listening could know it. We used the poetic reformulation of harmful prompts to more or less every LLM out there. It was 27 frontier models to bypass their guardrails for what concerns CBRN, so chemical, biological, radiological, and nuclear risk, loss of control risk, harmful manipulation, and cyber attack. So we asked to the LLMs to tell us how to enrich uranium in order to build a bomb, how to pollute let's say, the water system of a city with cobalt-60, how to run an automatic scripting for creating, let's say, a DDoS attack, or how could a model self-exfiltrate its own weights in another server and self-replicate there, this kind of, or how to write down an effective, let's say, fake notice from the public health ministry saying that vaccines are causing autism, and all this stuff, all this funny stuff that when you're doing jailbreak you try to do. And so we did with poetry, and we did with tales, cyberpunk tales, and they were pretty effective attacks. And when I say pretty effective, I mean that I think that the last attack that was as effective as our attack was the Do Anything Now attack from 2024. And if you are talking about single prompt attacks that are not automatic jailbreaks, of course. So it was super effective. We reached 100% on some models, attack success rate. On Gemini, it was like 93 or something like that on Google Gemini. And now we are going to get out with a new blog post on our website because we tested also new Claude models and new Gemini model. And the situation stays the same. That tells you that our attack surface is not just a trick. So it's probably a weakness that is structural to the way transformers work. So we didn't just find a way to do privilege escalation because there is one word that activates something and you just patch that word and it doesn't work anymore. Okay, so what I think we showed is that there is that this is a failure that you are not going to fix with a patch. That is inherent to the way LLMs work. And yeah, and we are working on actually, I'll say it out for the first time publicly. So we're working on a benchmark that we will release with thousands of prompts, and all of them will be adversarial, something strange from the humanities. So we used Vladimir's prop morphology of the folk tale in order to break the models. Then we used Hermete Trismegistus corpus hermeticum from probably 2,000 years ago, no, 4,000 years ago. So the point is that we found a trick that actually is not poetry, the point, okay, is whatever reformulation that is complex, cognitively complex enough, probably brings the model out of distribution. And now we are finally going to publish, let's say, the mechanistic interpretability analysis that we are doing on the attention heads of the model in order to understand exactly why it happens and where the model focuses in its attention when it gets jailbroken by this kind of stylistic reformulation.
One thing I think about a lot is that almost the first rule of application cyber secure development is sanitizing your inputs. And you can't sanitize your inputs in the same way with an LLM. You can't sanitize an idea.
Wow. Can we close with this? With Adam saying you cannot sanitize an idea. It's just perfect.
Well,
Yeah, it's
I
absolutely
think it's interesting. Reading your paper, I felt it was a bit like, I don't know if you've ever come across Patricia A. McKillop, who passed away, but she used to write these dreamy fantasy novels in a kind of a middle prose way, which left your head in a nice kind of fog. But nevertheless, you couldn't put your finger on why you enjoyed reading it and why the story was sort of a dull story but seemed wonderful. So there's a lot of this, and this, at least you've come up with one of the great examples of poetry over prose. So well done, you. Now, just before we close, I got kind of a final question, and both of you will kick in, I know. But Piercosma, you said, I think the phrase I wrote down was AI is more of an infrastructure than a product. And whilst I think I know what you mean, I wouldn't mind you unpicking that, because looking ahead, as AI is becoming more embedded in everyday products and decision making, including robotics, what do standards need to get right in that divide between infrastructure and product over the coming years?
So let's say in a nutshell, when I buy a toy, I buy an object. And this object is here with me. Is like I can say this is a toy because it has a space, it has a shape in the space. I can touch it and so on and so on. And there is someone who built that toy. There is at least one person or one enterprise that had the whole toy in their hands before packing it up and send it to me. Okay, so maybe pieces of this toy were built somewhere. Okay, but then someone needed to have this toy all done there and then ship it. Well, with AI, it's not like that. AI is embedded inside pieces of other products all the time, and we are regulating it as a product. It makes complicated our work, in my opinion, in standards. I'm talking for the trustworthiness frameworks that is targeting transparency, oversight, accuracy, robustness, partly logging, because partly is SC42 Adams project. And it has been very complicated to discuss with industry because they were raising some concerns that were legit, because they were like, I cannot check this out, this risk, because it's not pertaining to my AI system, is out of the boundaries of my AI system, and it's very complex to deal with that as it is only the AI system problem. Okay. And so I think that this is something that has been under considered for a long time. And that AI is not itself. I don't go around and sell AI products. Okay. Now someone is doing right now. Okay. But this is only the hype. It is going to end at one point. I go around selling products that will have AI inside. And this is problematic.
I mean, I think this is one of the main divergencies in terms of how countries are regulating AI. And I think that's spilling over into standards as well. I think there's divergent standards where people are thinking about AI as a product, the toy with the AI in, and there's standards where people are thinking about managing evolving AI services, organization.
We've covered a lot of ground, and just before I wrap up, Piercosma, any last thoughts you'd like to contribute?
Well, I think multimodal interaction will be the real future of the funny stuff. So stay tuned on that, I think.
Well, folks, it's been a heck of a round. We've covered the the importance of multimodal interaction, which is definitely something Piercosma wanted to raise. We've covered systems theory and Nicholas Luhmann. We've touched on a new law of robotics, perhaps. We have Adam's great contribution. You can't sanitize an idea, and a little bit of elucidation on AI as an infrastructure versus AI as a product, which is really live in the field. I'd like to thank you, Piercosma, very much for joining Adam and me here today to discuss this. And we look forward to many of the great things that you're doing over in the EU and at DEXIA on DEXAI, sorry, on researching these subjects and sharing your learning with us. And I would encourage all readers to go and read that absolutely fascinating poetry on using poetry to unblock prompts.
Thank you very much to you and to Adam for inviting me. It has been a real pleasure. Thank you for this conversation.